In this video, we will look at the PowerFactory energy analysis function. Two different methods will be demonstrated. PowerFactory energy analysis provides an evaluation of the profitability of power parks, such as wind farms. With this tool, which is based on load flow calculations, you can readily determine important quantities such as energy, and profit and loss for a power park, using network calculation results. To start with, the energy analysis of the wind farm will be carried out using the basic analysis calculation method, which executes a series of load flow calculations over the range of wind speeds from 0 up to the maximum wind speed under consideration. Ensure that the study case 3.2, basic energy analysis, is activated. The wind farm consists of 6 wind turbines, which are identically configured. Let us have a closer look at one of them. On the load flow page, you can see that the wind speed input model is selected. A wind power curve is assigned to the wind turbine, so that its active power output can be determined based on the wind speed set point. The reactive power output of the wind generators is controlled by a single station controller. This is done via a cos-phi-p characteristic, with Q being controlled at the wind farm 20 kV substation, close to the point of common coupling. The PowerFactory energy analysis command is found in the Economic Analysis Tools toolbox. The basic analysis method is selected, and the temperature dependency of lines and cables should be set to operating temperature. To define the boundary between the power park and the rest of the network, a boundary element called wind farm has been introduced at the point of common coupling. The agreed active connection power is the sum of the nominal active powers of the wind turbines, and is used as a reference value for the calculation of the full load hours of the power park. On the wind speed tab, we can provide the Weibull curve data for a single Weibull curve. This curve is used as a distribution function for the wind farm wind speeds. Here, feed-in and consumer tariffs are specified. On the Advanced Options page, it is possible to select Common, Leap, or Mean Year for the period under consideration. Execute the PowerFactory energy analysis. During the sweep over the wind speeds, the electrical losses in the network at each wind speed are calculated using load flow analysis, with the active and reactive power operational limits of the turbines being taken into account. The annual energy losses are then determined, using the Weibull distribution of the wind speed that was supplied. Let us have a look at the results in the plots. On the left-hand side, you can see the probability density plot for the wind speed, and below it, the cumulative probability plot. On the right-hand side, the top plot shows the active and reactive power at the point of common coupling with respect to wind speed, and the lower plot the line and transformer losses in the system. The associated report function can be used to show the evaluations of the energy and the economic analysis in the output window. The first part of the report shows the basic data of the power park, followed by the results of the energy analysis. You will find detailed information about average powers and energy data over a year, as well as operating hours and yearly losses. The report concludes with a summary of the economic analysis, showing the overall profit of the wind farm, and the impact of losses within the wind farm network. In the second part of this video, we will carry out the PowerFactory energy analysis using the probabilistic analysis calculation method. Activate study case 3.3. For probabilistic analysis, input parameters in the form of distributions are required. Let us look at one of the wind turbines. In the wind speed field, we can right-click, edit distributions and double-click here to see the assigned Weibull distribution. The shape and scale factors define the Weibull distribution used for this wind turbine. In addition, a copular element is used to establish a correlation between the wind speeds of 6 turbines in the wind farm. You can see that the correlation factor is set to 0.99. The higher the number, the greater the correlation. A factor of 1 would indicate perfect correlation. Notice that the voltage set point of the external grid is subject to a normal distribution. Here we can see the mean value and standard deviation of the distribution. The economic analysis toolbox should be selected. Open the PowerFactory energy analysis command. Once the probabilistic analysis calculation method is selected, the probabilistic analysis tool command can be accessed via this link. Here, you can choose between the methods, Monte Carlo or quasi-Monte Carlo, and specify the maximum number of samples. On the Advanced Options page, the seed for the random number generator of the probabilistic analysis can be either specified by the user or automatically determined. Other options, such as the tariffs and study year selection, are the same as in the previous case. Now the command can be executed. The probabilistic analysis processes the probabilistic data input and generates stochastic results such as distributions from which statistic quantities, for example mean values and standard deviations, can be derived. In the network diagram, results can be accessed in the result boxes of the network elements. For example, for generators, the averages of active and reactive power, their annual energy feed-in, and full load hours. In this project, there are also 2 additional result boxes summarizing some of the results for the wind farm as a whole. With the report function, you can display the calculated results of the expected annual energy yield, losses and profit. Confidence intervals can also be reported if the Monte Carlo method is used. The report in the output window first shows the PowerFactory data, then the results of the energy and economic analysis. This includes annual energy data, together with confidence intervals, as well as the annual electrical losses and the profit due to the corresponding energy feed-in. This button, Create Curve Plot, can be used to create an annual load duration curve for the wind farm. The annual load duration curve, in red, shows the PowerFactory active power at the connection point over the hours of the year. The brown line shows the energy equivalent at full load output. In addition, the diagram shows the mean value of the PowerFactory active power, with upper and lower 95% confidence intervals.